Welcome explorers, I am Astro Destroyer. In today's video I am going to discuss about Playfair Cipher, and I am also going to discuss about the explanation as well as the introduction part for Playfair Cipher. So without further ado, let's start the video. Okay, so now let us start by the introduction for Playfair Cipher. Now the Playfair Cipher was the first practical digraph substitution cipher. So basically this Playfair Cipher was a kind of substitution cipher where we arrive to the encrypted text by substituting the different letters as well as the characters which we have inside the plain text. And now the scheme was invented in 1854 by Charles Wheatstone. I am sure that many of you might have heard about Charles Wheatstone because you came across Wheatstone Bridge, right? So basically according to that concept only, he was the same person who developed that concept according to my opinion as well as knowledge, but it was unfortunately named after Lord Playfair, who promoted the use of the cipher. So here we can see that advertisement is greater than discovery or invention. And now let us move to the third point. The Playfair is significantly harder to break since the frequency analysis used for simple substitution cipher does not work with it. So the Playfair cipher is significantly harder to break because the frequency analysis, which we basically use for the conventional or for decoding the conventional substitution ciphers, simply does not seem to work with the Playfair cipher. So basically we have to work on some higher end stuff as well as develop some critical algorithms which is quite different from the simple substitution cipher ones to actually decode the Playfair cipher. And now finally let us come to the actual historical significance for the Playfair cipher. Basically it was used for tactical purposes by British forces in the Second Boer War and in World War I, and for the same purpose by the Australians during World War II. This was because Playfair is reasonably fast to use and requires no special equipment. So that is the main factor. If you have the significant as well as the useful resources as well as all the keys and all the necessary stuff which you actually need for encoding as well as decoding the plain text which has been encoded as well as decoded by using the Playfair cipher, you can do that in relatively less amount of time. And now basically a typical scenario for Playfair would be to protect important but non-critical secrets during actual combat. By the time the enemy cryptanalysts could break the message, the information was deemed useless. So basically if you don't have the, on the other hand, if you don't have the necessary resources as well as the key for decoding as well as for decoding basically the plain text which has been encrypted by using the Playfair cipher technique, it would take significantly longer time as well as a lot of banging your brain as well as head on the wall to basically decode the text which has been encrypted by using the Playfair cipher. So basically this would basically take the time for decoding, and the enemy cryptanalysts would take much more time as well as much more resources for breaking the cipher text. So basically this was the main reason why this was used in the world wars, and even if they could break the message by using some tactics as well as other algorithms, brute force algorithm, whatever, it would take significantly longer time until which the message would be deemed useless. So that is the main reason the significance of the Playfair cipher can be felt in the World War I as well as II in those periods of time. And now let us move on to the explanation for the Playfair cipher. Now I will basically discuss with you the basic algorithms or the step by step procedure for the Playfair cipher encryption as well as decryption. Now let us get a very naive introduction as well as introduction for the explanation for the Playfair cipher. Now first of all you have to input the plain text or take the plain text as input from the user, and then you have to input the key as well, and then you have to convert it to an intermediate string. That is, you have to convert the plain text to an intermediate string. I will later tell you how to do that. And then you have to create a reference table, and after creating the table you have to apply the norms of the Playfair cipher on each of the pairs of the intermediate text by using or taking the help of the reference table, and in the due process you have to keep on generating the cipher text, and later you have to print the encrypted text and then you have to decode the encrypted text by using the reverse procedure, exactly the reverse procedure which you actually used for encryption. And after the decryption process, you will have to print the decrypted text. So this is basically the overall algorithm which you basically follow for encrypting as well as decrypting any plain text by using the Playfair Cipher technology. And now I will basically give you one simple example as to demonstrate how you can actually use the Playfair Cipher. So now let us take one example. So basically, first of all, you will have to take the plain text as input from the user. I will basically denote it like this, and suppose I will basically explain you with a simple example which I came across while searching for this cipher. Now let us suppose that the user has entered jazz as the plain text, and he has also entered the key. So you can take anything as the key. So I will take the same example which I came across by searching for the cipher on the internet. Let us take the key as monarchy. Sorry, it will take some time because I am not habituated to writing all this stuff by using the simple mouse. I don't have any specialized technologies also for doing that. So after taking the plain text as well as the key, we basically have to encrypt it. But before that, you will have to create the table. And even before creating the table, as per the algorithm which we are following today, we have to basically generate the intermediate text. So let us denote it by IT. So intermediate text can be basically generated by following some simple procedure. So the first procedure is the first step is that you will have to find or go by each character. Suppose you have the cursor here at this moment pointing towards J. So okay, we are pointing towards J now, and you have to see whether the next character for J is same as J or the character which is here itself or not. So if the character is also the same as the previous character, you will have to add one X to the intermediate text. But here it is not so, so you will have to write J as it is, and after the cursor will point towards A. So again you will have to see if the previous one is the same as this one or not. So here as you can see, that A is not same as J. So for that, basically we will have to write the same thing, but after that you will have to also check whether this character is the same as the next character or not. So as you can see, A is not same as capital Z. So we will have to basically write it as it is. So J is, and after that the main trick comes for the generation of the intermediate text, and the cursor has moved here after printing A. So here it is. So we are now at capital Z, and you have to check whether the previous one is the same as this one or not. So capital Z is not same as capital A. So after that you will have to also check whether capital Z is same as the next one or not. So this character here is not same as the next character. Sorry, it is same as the next character. So for that basically you have to append one extra character which is X here. Okay. And after that you will have to also check by moving your cursor here after printing the ZX, and after that here we are at this moment we are here at capital Z. So it is the last character for this sequence of characters for the plain text string, and here as you can see the previous character is the same as this character. So no offense for that, but after that you don't have any character. So because of that you will have to write capital Z and X. Don't worry, I missed out a few points by about discussing the plain text or the part of generation of the intermediate text. So don't worry about that. I will also explain by taking another example. But for the time being, this intermediate text has been generated, and now we are basically interested in generating the table or the reference table, whatever you can say. So now let us generate the reference table. So reference table we are going to generate now. Okay, so the reference table will basically be a 5 cross 5 table. So I am writing it here 5 cross 5. Okay, so basically it will consist of 5 rows as well as 5 columns. And after that, let us generate the reference table. So for generating the reference table, you will have to basically write each of the characters which we have in the key string. So you will have to basically write like this. Suppose we have the key as monarchy, right? So we have to generate the reference table like this. First write M O N A and R. So basically, as you can see, we had successfully written the first row for the reference table, which consists of 5 elements. And now let's move on to the next row, and what comes after R in the key? C, right? So you have to write C and similarly H and then write Y. So as you can see, we have exhausted all the characters which we have in the key string variable, and basically we have to fill the remaining part of the reference table by using the remaining characters of the English alphabet. So let us start by A. So A is already used in this reference table. So what comes after A? You have to put B, because B has not been used. And what comes after B? C. C has been also used. So after C we have D. D is not used. A, B, C, D and then E, which is not used previously, and then F also not used, G also not used, H is used, sorry, G, H, I, and I and J are considered to be the same here, so you have to write like this, because J is also not used. And after I, J and K, K is also not used, so you can write like this, I, J, K, and L is also not used, L, but M is used, M, N, O. Okay, so M, N as well as O has been used, and after O, M, N, O, P. Okay, P has not been used previously, M, N, O, P, Q. Q also not used, R has been used, S has not been used, Q, R, S, T, U, V, W, X, and Y has been used, so you can write Z. So this is basically the reference table. As you can see, this denotes row number 0, this is row number 1, this is row number 2, this is row number 3, and this is finally row number 5. And similarly for the columns also, this is column number 1, sorry, this is column number 0, column number 1, column number 2, column number 3 and column number 4. So finally we have 5 rows as well as 5 columns. And now basically we have generated the reference table successfully, and now we have to write or encrypt the plaintext. So for encrypting the plaintext, we will basically go for each of the pairs of characters. So as you can see, we have even number of characters in the intermediate text. So basically we have 3 pairs or 6 characters. So for each of the pairs, suppose for the first one, for the first pair, the first letter is capital J. Now as J and I are considered to be the same or overlapping, by using the reference table we are basically going to do that. So suppose the first character for the first pairs of characters is J. So and the second one is capital A. So here it is I N J and the A is here. Okay. So the first rule says that if both the characters in each of the pairs are belonging to the same column, okay, so you will have to take the characters in the same order just below the characters in the respective manner. So what does that mean? So for example, suppose you have JA and the first character is J, okay. So J and A belong to the same column, and the character just underneath J is capital S, so write S. And similarly, the character under capital A is B, so write B. Okay, so we have generated the ciphertext for the first pairs of characters in the intermediate text, and similarly for the next pair also the first letter is capital Z, so encircle Z, and then we have capital X. Okay, so the second rule says that if you have the characters of each of the pairs of any pair belonging to the same row, then you will have to take the character exactly right or to the immediate right of each of the characters in the respective manner. So this also basically means that if you have Z as the first character in this pair and X as the second character or any other character, then you will have to take the character which is immediately right or belonging to the right side of the character. So the first character is Z, the right side will be the wraparound condition, will go like this, pointing towards U, and so you have to write U. And after that do the same thing for X also, whose immediately right shifted character is Z, so write Z. And for the last pair also, which is basically ZX, the same one, so you have to write the same thing. So you have to do this for each of the pairs of characters and repeat the same procedures. Now let me take another example. Now basically this is the encrypted text. We are basically going to denote it by ENCPT. In the upcoming code for the encryption, you can clearly see the difference. Okay, so this is the encrypted text, this is the final one. And now suppose let me take another example. This was a very trivial example actually, we couldn't use all the rules. Now let us take another example for this. The plain text here you can suppose hello. Okay, so we are taking hello as the plain text. We are basically interested in encrypting this plain text. And let us take the key as monarchy for simplicity because we don't have to generate the reference table again and again. Okay, so monarchy. The key we are taking, what we are taking is monarchy. Okay, so basically the intermediate text we are basically going to write like this, IT. Okay, so now the pointer is here for the plain text. The next character is not the same as this character, so write H as it is, and after that the pointer will move towards E. The previous character is not same as the present character, and the next character is also not the same as this present character, so write it as it is, and after that the pointer will again shift one place forward, and the previous character is not same as the present character, but the next character is the same as the present character, so you will have to write like this, L, and then write one X, and the pointer is again moving forward, and the previous character is the same as the present character, but the next character is not same as the present character, so write it as it is, and pointer will move towards the last character, and the last character's previous character is not the same as the last character, so you will have to write like this. So this is the intermediate text, and the reference table is as it is. Okay, so the reference table is as it is. So now as you can see, we have written the reference table once again for the monarchy key, and now after that we are going to write or encrypt the plain text for generating the ciphertext or the encrypted text. So now for the time being we are basically going to encrypt the text. The plain text has been converted to the intermediate text, and by using the intermediate text for each of the pairs of the characters which we have in the intermediate text, that is these three pairs, we are going to generate the encrypted text. Now consider the first pair, the first character is H and the next character is E. So H, find for that in the reference table, it is here, and the capital E is here. So as you can see, so this is where we have to make use of the third rule. So the third rule for encrypting says that if you have the two characters present in any pair as not belonging to the same row as well as to the same column, then you will basically have to go by the diagonal for each of the or you have to go by the diagonal and form a square. Suppose the first one was H and the next one was E. So you have to form a square like this by taking the 2 points as the diagonally opposite points, and by making use of the other 2 points also you have to generate one square, and for each of the squares generated by using the 2 characters present in the plain text or the intermediate text pairs of characters, you will have to find the letter which belongs to the same row and also belonging to the same corner of the square formed by using this procedure. So the first letter here is H, and so if you go by the row wise fashion, then we have come across C, which is also a corner point for the square formed. So you will have to write C. Okay. And after that the next one is capital E, and so here as you can see by going row wise like this, we come across F, which is the corner of the square formed. So write F. So we have successfully encrypted the first pair of characters which we have inside the intermediate text. And now the second pair, which is capital L and X. So find where is capital L. It is here and X is here. So again the same thing, form a square like this. Sorry, it is not a square. Sorry, basically you can form a rectangle or a square, because every time we will not be getting a square. So whatever, it will have 4 corners, and for the first character which is L, you have to go by the row wise fashion, and so here as you can see we have come across S. So write S. And the next one is capital X. So for X we have gone the row wise fashion, and we have come across the corner point which is U. So write U. And after that the last pair which is LO, and find LO. L is here already marked and O is here. Okay. So generate one rectangle. Okay. Sorry, it is getting a little bit of confusing as well as congested, so forgive me for that. And so here we have found capital L. So as you can see capital L is here, and so go by the row wise fashion, and here we have capital P. So write capital P. And after that the next one was O. So here go by the row wise fashion, and the corner point is M. So write M. So this is basically the final encrypted text which we were searching for. So this is the encrypted text. So this is how you can actually encrypt one plain text by using a key as well as a reference table, which is basically formed by using the key. So we have taken 2 examples. The first one here was the example of plain text which we had taken as jazz, and the key was monarchy. In the second example also the plain text was hello, but the key was monarchy. So this is how you can basically encrypt any plain text by making use of a key by using the Playfair algorithm. So the decryption technique is also quite similar. You can actually learn that if you basically want, but simply the encryption technique is what we are basically trying to figure it out. So that is all from this video, guys. I hope you enjoyed this video. If you really enjoyed the explanation for the Playfair cipher, I am basically planning to introduce the coding part for the encryption as well as the decryption separately in my next video. So if you like this video, then don't forget to give it a like and also subscribe to my channel for further interesting updates. I will come up with some other interesting topic, and the next video is basically going to be the encryption coding part for the Playfair cipher. And until then, so basically this was all from this video, guys. Hope you enjoyed this video. If you really enjoyed this video, then don't forget to give it a like and also subscribe to my channel for further interesting updates. I will come up with the encryption coding part as well as the decryption part also for coding. Until then, keep exploring.